Impulse is the change in momentum of an object. Now, because impulse is the change in momentum, it has the same units as momentum. Following Newton's second law, we can see how force is related to the change in momentum. If you think about changing an object's momentum, for instance, if it's moving and then you stop it, you have to apply a force. If you apply a force over a certain time, you can change a momentum. I like to call this equation fat ap. When you kick a soccer ball, you impart a force on the ball. This causes the ball to move forward. But this collision doesn't happen instantaneously. Time passes. And this time passing allows a change in momentum of the ball, which is what causes it to move. Most collisions take anywhere from 1 millisecond to 10 milliseconds, and that force is imparted in that time. This is when objects deform or morph into the bat or the ball, etc. The force versus time graph looks something like this. There's a large spike in the middle. The area under the curve is the impulse imparted. Rather than taking an integral, we take an average of this force imparted over time. This gives us a pretty good approximation. Here we have an example of a ball colliding with a wall. It is a mass of 0.25 kilos and will give it an initial velocity of 1.3 meters per second to the right. It's going to collide with the wall of science, and it's going to collide and come off with a velocity after the collision of 1.1 meters per second to the left, or negative 1.1 meters per second. The speed of the ball decreased, which means that the kinetic energy was not conserved, an inelastic collision. What is the impulse imparted? To find impulse, we need to know the change in momentum. Just like finding the change in position or the change in velocity, it's P final minus P initial, or final momentum minus initial momentum. You plug in your initial and final velocities and you get your impulse. In this case, we have a negative impulse, which means that the impulse was directed to the left. We can use impulse to talk about why long-legged people, on average, can jump higher than short-legged people. We all have a maximum force that our legs can apply to the floor. But if we have longer legs, we can increase delta t, or our contact time with the floor. If delta t goes up, that means our change in momentum has to go up. We leave the floor with a higher velocity and jump higher. Why do frogs have longer legs? If you look at a frog's legs, they are really long. This is so it can generate the greatest change in momentum. Why would it need that? To evade predators. See, physics is actually saving this frog's life so it doesn't get eaten.